Now, the universe is a big place, and it is packed full of all different materials that can come in different shapes and sizes, all these different properties, things that are harder and softer, things that are colorful, things that are solid, things that are perhaps more sort of powdery. I'm going to have red hands now. There can be liquid materials. You get watery objects. You are made of materials. Even fire, okay, is the result of incandescent carbon particles as they react with the oxygen and the heat, okay, they're glowing. There's a whole series of different properties belonging to all these different materials. All of these materials can be made from all of these elements on the periodic table. Basically, what these show is that the vast majority of all the elements in the world, the sort of building blocks of all materials, are these metals over here. There's actually only a few non-metals indicated by the sort of bluer sections sort of over here. The rest are all, like I said, all metals with the exception of hydrogen. So the vast majority of them are therefore like similar properties to these metals, and so they would be solid at room temperature. There's actually very few of them that are not solid at room temperature. And all these materials are not really made of these large things that we see. They're actually all made up of little tiny particles, a bit like these coins jittering around, constantly in motion, constantly got motion, have constantly got energy. They're arranged differently depending on whether it's a solid or a liquid or a gas. So in a solid, all our particles just vibrating ever so slightly around each other, but not really moving anywhere, not changing their overall position. In a liquid, they're much more free to move, but still attracted to each other, so they sort of go round and round and interact with each other. As you start to heat them up, they start to move faster and faster. Eventually, they may become a gas, and gases have broken free from these forces of attraction. And so they'll just be zipping around, bouncing off things, crashing into each other, and moving really, really quick. Any properties referring to these particles, we would call them microscopic. They're so small, we can't see them. In fact, a lot of this stuff is actually theoretical, and scientists have to work out what they get based on different experiments and observations, and they make inferences and predictions and mathematical models and models like this to work out what's actually happening. So if we have the larger objects, then we talk about the macroscopic properties. So macroscopic properties are the bigger sort of everyday properties, things that big things like humans can actually see and interact with. So let's look at some solids. We already saw the little beaker full of 1 yen coins. These are solids, solid metals. You can easily play with them. Oh look, my fingers have gone red. Put them in there. I've got some clay, quite different, okay, much softer, doesn't make a sort of jingling noise if I mix it round. But one thing that they do have in common is their ability to pour. By that, I simply mean how well you can put one thing into another. Okay, I can pour it this way, that way. It doesn't really pour out, it just sort of falls out. I mean, the clay, probably a better example, watch. So they don't really care about the shape of whatever thing I put them in. Whether I just drop them on this bench, okay, or put them inside the beaker, or even just throw them on the floor. The actual macroscopic properties don't really change unless I give them a good bit of energy or force. So I could maybe heat them up and try and melt them and change them that way, or actually do some chemistry or pure physics and really force them to change. liquids too. They are also a system of particles. And depending on these microscopic properties, depends on these larger macroscopic properties. The fact that these particles are interacting with each other, but a little bit more freely, there's less stronger attraction between them, then means that they can flow easily like this. If I try to pour them, they take up the shape of whatever vessel I put them in, even if it's a slightly more, go that way, it was a slightly more strange shape. Okay. They will always take up that sort of shape of the vessel that they're in. Always sink down to the bottom as well due to gravity. And just for clarity, I tried to make it a bit bluer. Now what I've done here is I've actually turned this solid into what looks like a liquid. And that's true, it behaves like a liquid. This is actually a special case. It's a solution. What I did was I put this sort of blue powder in here, which is a type of blue food coloring. And when I added that to the water, it dissolved. And so it makes this blue solution just a bit easier to see is all. So now I've got some solid particles dissolved in my liquids, and the macroscopic properties, we'd say, well, it just behaves like a liquid. So how about for a gas? So the gas, the particles are much freer. They're so free that we can't actually see a gas. But if I press this button, you might be able to hear. There's actually a gas coming out of here. What type of gas? Well, we can find out. We can find out by looking on the label. Okay, nice and easy. So we saw hydrogen. So let's look at hydrogen gas. There's other ways to test for different types of gas because all these different gases, solids, liquids, we said although they have similarities, they also have different properties. And gases too are no exception. Now, sure, gases are all the same. You couldn't say this is a hard gas or a soft gas, but you could do other tests. So let's do another test. So I added some just some liquid soap into the water. That, like the food coloring, dissolved. I'll add a bit more of this blue stuff just so we can see it easier. There we go. Now what I can do is, because gas is much less dense, that means the particles are more spread out than water, like we saw from our microscopic diagrams. I can actually put some of my hydrogen gas into the water, and you can see it. Let me zoom in a bit. You can actually see it's bubbling up. It's creating these bubbles. That's the gas. Bubbles are just filled with gas. They float to the top like that. So now I've got some hydrogen trapped. Let's see what happens when I put some fire next to this trapped hydrogen. Woo!